we think about what we did yesterday, what did we test? Different kinds of, Abby?
Materials.
Materials. And what did we generally come up with as pretty good materials? There were several that were better than others. Noor?
The 10 coffee filters and the sponge.
Okay, coffee filter, sponge. So I ended up just writing it down here after you guys discussed it yesterday, that we had aluminum foil with one hole. A lot of people like that. Coffee filter, sponge, felt, or we could even use a combination of that. I remember Adam said, oh, maybe if I fold this and put this. So he's already thinking that maybe a combination of different materials might work well for your design. So today, you're actually going to be doing the next step in the engineering design process. There's one more thing, though, I want you to think about. In your notebook, you have another page. I would just like you to take like 5 minutes to quickly answer this. And that's like wrapping up the whole ask process in the engineering design process, the ask step. So what function do you want your model membrane to have? What do you want your model membrane? But what function? What do you want it to do?
Drop slowly on the front.
Absolutely. Enough water to pass through. You guys can have a conversation at your group about a question if you're stuck. All right, take 30 seconds and share at your group what you have for your ideas right there. 30 seconds. Quick, quick.
I want my model membrane to drop drops of water slowly and shield bad stuff out.
All right, engineers, thank you for sharing that with one another. Are you ready to now begin the real hard work? Well, actually, the hard work is done. You've asked all those amazing questions and figured out all the things that can work and what can't work. And so now comes the next stage of the engineering design process, the imagine. What are some solutions, brainstorm ideas, and choose the best idea. So in this stage, okay, this is done independently. So today, our guiding question is, how can we use our knowledge of the model membrane materials that we tested yesterday, the functions of membranes, allow something to pass through, others not to pass through, the rate at which it passes through, tiny holes, and the engineering design process to design a model membrane. So today, my friends, you are thinking about what is it that your model membrane can look like? How can it work? Again, you have the same plastic container, okay? But when we test it, today, when we think about testing it, you're going to think of an idea, imagine it by yourself, plan it together, one plan, and then today we're actually going to create it. We're actually going to make it, put a little frog in the bottom, pour some water in it, and this cover, can you all see it? The cover actually fits on this plastic container. You have the same materials as yesterday. You have sponge. I even cut some extra sponge. We have felt. You can cut it. You can cut this. You have scissors. You want to cut. You create, cut, whatever you want. Got it? So now you understand the things you're working with. Is everybody clear? Okay, here we go. Next clean page. Okay, on the top of this page, your title is Imagine. And right in the middle of the page, please draw one line, because you're going to have an Imagine 1 and Imagine 2. When we put the water in, how much are we pouring in? Does everybody know? 1/2 of a cup. We're going to leave it overnight, right? How will we know our model membrane is working? Julia, what do you think?
Either there wouldn't be any water left, or it doesn't go down too hard.
Okay. What if there's no water left? How will we know that that didn't pass through in the first 5 minutes when we made it? Like the screen and the cheesecloth. Nathan, do you have a thought about it?
Well, maybe if there's no water left, that means that maybe the materials we used for it are have too much holes in them, and we need something with less holes so the water can stay overnight.
Okay, so how about if we decide this? We pour the 1/2 cup in, and tomorrow morning when we check, right, it'd be 24 hours, when we check, should there be a little bit of water left in the container? Yeah. Okay, there should be some. That way we will know the rate that the water passed through was kind of slow, and it allowed for the frog to meet its need. Would we agree on that? Do we want all the water to pass through in 24 hours? No. No, we don't. We want some of it. How about if we say half of it? Would it sound right? Like half of it? About half of it, about a fourth of it. So if we have a half cup, about a fourth of it can pass through, and we still want some left in our model membrane. Make sense?
I want to see which one's going to be better. Yeah.
I'm just thinking too, I know you're really in deep thought. I hate to interrupt you, but I'm just thinking too, do you definitely have to use 10 coffee filters? Okay, I'm just saying, you don't have to use 10. You can use 10, but you don't have to, right?
I have the sponge, and I have one piece of felt, and those are the drops of water dripping onto my frog. And for my second imagine, I have only 5 coffee filters because I think that 10 is too much and it'll take too much time to seep through. And I also have a piece of foil without any holes because that seemed to work pretty well in our experiment yesterday. For me, I really think that that one might do better than that one because it has the sponge, but this one might do better than that one because it has only 5 coffee filters.
I was looking back at what I had written down about the materials, so I knew what materials I could use. The first thing I thought of was putting the aluminum foil with one hole because that fell kind of fast. And then I put the coffee filters because the coffee filters yesterday went really slowly. So I thought if I put the coffee filters in front of the aluminum foil with the hole, maybe it'd go a little bit slower.
You've done, what are some solutions? You brainstormed ideas as an individual team member of your engineering team, and you're choosing your best ideas, okay? Now, you need to draw a diagram, make a list of what you will need. However, this doesn't happen just like this. How many members are in your team? 3. You have to value one another's ideas. You come up with one plan. This doesn't happen in 2 seconds. You have to communicate and respect everybody's ideas. Maybe parts of Thomas is going to work really well with parts of Abby's, which is going to work really well with something Devin was thinking about. When you've decided what you think will work best, after each one of you shares your 2 ideas, you decide on one final plan. You will build your plan just the way you planned it, okay? So the first step, have a conversation with your team members about what you have. Go.
Okay, so I have 5 coffee filters, and I'm gonna put a sponge inside the coffee filters. It's kind of like yours, except I added the sponge under the coffee filters.
Well, this one had felt, 2 sponges, and a lemon foil one. Why would you put the felt though? Because it fell straight through it. But she didn't put the felt just there. She put 2 sponges and aluminum foil. I put the sponge because at first it was just dripping and then it fell straight through. But maybe if we put the aluminum foil with no holes over the sponge, maybe all the water won't fall through all at once. Maybe it'll take a while.
Maybe if you put the aluminum foil with one hole and then the sponge.
Because at least it's one little hole. But it's still,
Remember when we took the aluminum foil with one hole, it was just
drip, drip, drip. So when it drips from there, it will go to the sponge, and then the sponge will drip on the top. What do you think should be on it? Well, if we go into the testing model membrane materials, that we could definitely use a sponge because the sponge, it wasn't like the felt, but it just went like that, and so it would take a little bit of time for it to sprinkle down, so this way you less pressure for the frog to take in.
Exactly. And did you put sponge in your first imagine? So you're kind of agreeing that might, based on what your data shows you. Good.
I think this is going to work out, definitely.
Okay, so you guys share that one with Victoria as well.
Go ahead. What did you have? What kind of materials are you using? House sponge and sponge, pretty much. You're just using the sponge?
Okay, so I think
Because she did sponge, we should definitely consider using the sponge. So we're gonna do. Do you agree? I need to add something. I think after we have the sponge, that we should have the felt. Two coffee filters. 2 coffee filters. Can you give me an idea why you would like that? Because if it's just the sponge, it's gonna drip down as soon as it gets heavy. And then after that, there's no stopping it.
It's missing something though.
That's why I put.
What would happen if we put 2 coffee filters?
I'm thinking maybe if we take away this sponge and put coffee filters. No.
Maybe because it folds. The sponges are bigger. Maybe we'll take away
One sponge.
this bottom sponge
And then put the coffee filters.
coffee filters. Put 5 of them because it fell really slowly. Remember that?
Or we can put 2 coffee filters with the 2 sponges.
Oh yeah. Why don't we just put 2?
How are you guys doing?
Doing
Do you have a
pretty
plan?
good.
We're still making up a plan.
Still thinking, still talking? Okay, do you have a basic idea yet?
So far, we've come up with the aluminum foil
Okay.
over 2 sponges, and then we'll put 3 coffee filters.
Okay, why did you decide on 2 sponges? Is that a decision you all made?
Yeah, because
Thank you.
coffee filter. Well, now that we're gonna put the coffee filters, if we take away 1 sponge, put 5 coffee filters, it may be better than just having 2 sponges and then 2 coffee filters.
What do you think, Vivian?
I think 2 sponges and 2 coffee filters is probably better. Because I think the sponges are like a little bit thicker than coffee filters.
10 coffee filters were 1.5 cups, so if we do
Oh, I like how you went back to that.
5, and then we take away 1 sponge, because 1 sponge went 1/4, so if that would go waste, maybe we do 5 of them.
Maybe we should.
What do you think, Nathan? You understand why they're saying that? They're looking back at the data. Understand? Yeah.
Wait, 1 sponge went 1/4, and then the
10 coffee filters went 1/8 cup.
yeah,
So if we take away 1 sponge, that would be 1/4, and
we'll
then
make it slower.
make 5 coffee filters instead of the other
What do you
sponge.
think? Wow. And you know what? And if, you see how that works when you test it out, and then what could you do
If it doesn't work,
if it doesn't work?
turn it back.
Yeah, you can change one of those, right? So then you can improve it, right?
Yeah.
It sounds like you guys are a good team.
Yeah, because the sponge, I think, is the best part of this.
Yeah, because it passes through more slowly than
Yeah, because the water will be absorbed. The sponge will absorb the water, which is making the water stuck in there, and some's going to come out in a little bit. It's going to keep coming out in a little bit. It's not all just going to come out at the same time.
the sponge goes in first.
Okay, so the sponge goes in, and then the
Maybe we could use 2 holes. No.
Hey, I'm going to be very careful with this. This is the moment of truth, baby. We're all sealed up. Was it? There you go.
So one team at a time can come up, bring it. Don't forget to bring your lid with it.
Oh no, yeah, it's dead.
Okay, wait. It's a lid. Don't move it.
dead.
Don't move it.
He's just dropping on him. That's awesome. Oh my god, it's not working. Oh yeah. Bye, Floggy.
All right, lid. Okay. Next team.
I think ours is gonna go through the side down aluminum.
Okay, ready?
I
Watch.
need to put the cap on.
Okay, but gently.
See, it's going through the side. But it's. See, it's supposed to make sure we get it right.
Kind words. Thank you very much. Ooh, looking good.
No, really?
what's happening? It's going through the sides of the... It's okay, the froggy can live.
You're right, Nathan. He can live. He's not drowning, right?
Oh, man.
What do you think?
Oh, look at that poor frog.
What do you think?
I think that we need to improve.
Right? Who just said that before? Nathan said it. Nathan, what did you say about your observation?
Froggy can live.
Okay, but what did you say about your observation? What's happening with yours?
It's falling a little too fast.
Okay, their team, they just recognized it. It's falling a little bit too fast, and he said, well, don't worry because the frog can live, right? Because frogs can live on land and in the water, okay? However, I just heard Adam say something. Adam, what did you say?
I think that we need to improve.
Why do you need to improve already?
Because it's going a little bit too fast.
Okay, did anybody see yours coming out trickling pretty slowly? Okay, so when will we definitely know? Tomorrow morning. Congratulations, engineers. You just completed the first big step in making a model membrane. Awesome job. Well, lesson 4, it's actually the most exciting lesson because it's the one where they can actually finally start to imagine, make a plan, and create it. They've been building up to that for several days, and they're really anxious to succeed. The thing with that is they don't always succeed right away, and they have to learn that that's okay because that's part of the process. Up until, usually by lesson 3, there are a lot of pieces that they need to have in place for the materials, understanding all of that. So I usually use the worksheets with those lessons. But when it comes to lesson 4, I like them just to put it in their science notebook. So for example, they just put imagine, and then they just write. I'll use the worksheet as a guide for them to put it in there, and you'll notice that when you see them writing in there. But I like it to be mostly their work and less worksheet. But with this, they always go back to the worksheets from lessons 2 and 3 to kind of justify why they're making a selection of a material. Really encourage students to work as a team. Doing this for 8 years, I think that's the toughest part, and I keep reiterating that because it is a tough part for kids to realize that their way is not the only way to think about it, and that engineers work with teams and value one another's opinions and ideas because that in the end could make the product that they're really looking for. So now when we get to the improved part, groups will share out what worked well. And I think that's really valuable for them because if something worked well for one group, that might inspire somebody else to think about, gee, maybe we could consider that for our improved.